Hey everyone, welcome to week 7 of BinaryTree's comprehensive curriculum. Last week you wrote your first Python programs. This week we make them powerful. We're learning data structures, the organized ways real programs store information, specifically lists, tuples, and dictionaries. Then we'll look at libraries which let you borrow tested code instead of writing everything yourself. This is where Python starts to genuinely feel useful. Let's go. Quick recap. Last week we covered Python fundamentals, data types and variables, print and input, operators and conditionals. This week we extend all of that. We're adding data structures, libraries, focusing on the lists, tuples, dictionaries, and some of Python's most popular libraries. The goal is to understand how real-world programs actually store and manage complex data. So, what is a data structure? A data structure is simply an organized way to store and manage related information. Instead of 100 separate variables, a data structure lets you group items together and work with them as one unit. Python gives you several powerful ones built right in. Today we focus on the three most important: lists, tuples, and dictionaries. Each has its own personality and is designed for a different job. Let's start with the most common one you'll use: lists. A list is an ordered collection you create with square brackets. In this case, a list of fruits. You can access items by their index. A crucial thing to remember is that indexing starts at 0. So fruits index 0 is the first item, apple. Lists can hold mixed data types, and best of all, they're mutable, meaning you can change what's in them and the order. Notice append, which lets you add an item to the end of a list, and the length function, len, which tells you how many items are in a list already. Lists grow and shrink and replace items as you need them to. Now the tools for working with lists. These are called methods. To add something, we use append or dot append, which puts an item at the end. To remove, we use dot remove, which deletes a value, while dot pop deletes by position. To find, we use index, which tells you where an item is, and count tells you how many times it appears. And to sort, we use dot sort, which reorders the list itself, while sorted gives you a new sorted copy. Append, remove, pop, and sort are the four you'll reach for the most. Now it's your turn to build. Write a program that does 4 things: create a list of your favorite movies, add a new movie to the end, remove one you no longer like, and then print the final list along with its length. Try it before you peek, and here's the solution on the screen: a movie list, which has Inception, Interstellar, and The Dark Knight, then an append, which appends Dune, then remove, which removes Inception, and then we finally print movies, and then its length. Next, the list's stricter cousin, the tuple. A tuple looks a lot like a list, but you create it with parentheses instead of square brackets. Here's some coordinates and an RGB color. You access items exactly the same way, by index. But here's the one defining difference: tuples are immutable, which means once you create one, you cannot change it. Try to, and Python throws an error. That sounds limiting, but it's actually a feature. It's faster and it lets tuples be used as dictionary keys, which lists can't. Use tuples for data that shouldn't change. So how do you choose between them? Use a tuple when your data shouldn't change. Coordinates, dates, a configuration. When you need fast, read access, or when you want to use it as a dictionary key. Think of a GPS location or an RGB color. Use a list when you need to add, remove, or change items, when the collection will grow or shrink over time, or when order matters and things may change. Think of a shopping cart or a friend list. The rule of thumb: if it changes, use a list; if it's fixed, use a tuple. Now the most powerful of the three, and my favorite, the dictionary. A dictionary stores information as key value pairs, like a real dictionary where each word gives you a definition. On screen, a student's dictionary maps name to Alex, grade to 11, and so on. Instead of accessing by a number index, you can access by the key. Student name gives you Alex. Can add or update a value just by assigning it to a key, and you can check whether a key exists with the in keyword. Keys must be unique and unchangeable, but the values can be anything, even lists or other dictionaries. Here are the key dictionary operations. To access safely, you can use square brackets, but .get is faster. It lets you return a default instead of crashing if the key is missing. To remove, .del deletes a pair and .pop removes it and hands the value back. And to loop through everything, items give you each key and each value together, perfect for a for loop, like printing every student and their score. You can also grab just the keys or just the values on their own. Get and the items are two you'll use constantly. Now let's build something real. A student grade system. Your task: create a dictionary of students and their grades. Add a new student, update an existing student's grade, and then print everyone. Try it first, and then here's the final solution. Start with the grades dictionary. Add Dave by assigning a new key. Update Bob by reassigning his key. Then loop with .items to print each name and grade. Notice the F string in the print, which cleanly drops variables into text. We've got our data structures. Now let's talk about how to supercharge Python with libraries. Libraries are collections of pre-written, tested code that extend what Python is capable of. So you don't have to reinvent the wheel every time, and you can borrow from other people before you. You pull one in with the import statement. Some are built in and come with Python: random for random numbers, math for calculations, datetime for dates, JSON for web data. Others are external and need to be installed with a command called pip. Requests for the web, pandas for data, NumPy, matplotlib. Libraries save you enormous time by handing you efficient solutions to common problems in the form of function, one-line things, and these functions are pre-invented in the libraries. Let's see how this all comes together in the real world. In web development, dictionaries store user data and API responses. Lists manage collections of users or posts. Tuples represent database records, and the requests in JSON libraries move data to and from the web. In data analysis, lists and dictionaries organize huge data sets. Pandas processes spreadsheets and databases. Matplotlib turns numbers into charts, and random generates test data. These structures are the backbone of real software. Now let's apply it. Imagine you're building a social media app. How would you use lists, tuples, and dictionaries to represent three things: user profiles, friend connections, and posts with comments? Which structure fits each one best, and why? Take a minute to think it through. Pause the video before I give away the answer. What I think is that a dictionary fits a user profile, mapping fields like name and age to values. A list fits a friend list or a feed of posts, since those grow and change, and a tuple can hold fixed pairs like a coordinate or an unchanging record. So to wrap everything up, lists, tuples, and dictionaries are fundamental building blocks of Python. Each has a specific strength, and you choose based on one main question: does the data need to change? Libraries then can massively extend what you can build. Combining structures lets you create complex, powerful programs. These exact concepts form the backbone of both web development and data science. So you've just learned tools that professionals use every single day. And that's week 7. You now know how real programs store and manage data and how to borrow powerful tools with libraries. That's a huge step up in what you can build. Next week is our finale, and it's a big one. Artificial intelligence in your day to day life, how it actually works, and how to use it. See you then, and I hope you had a good time.